All right, so this video is covering section 5.2, which deals with polynomials and adding and subtracting polynomials. So the first day, our goal or our objective was to be able to find the degree and leading coefficient of a polynomial and to add polynomials. So in order to do all of this, we need to know what exactly a polynomial is. So a polynomial is an expression with constants, which we know are numbers, variables, which we know are letters, and exponents that involves adding, subtracting, multiplying, and dividing. So everything is a polynomial except an expression that has a variable in the denominator of a fraction. So for example, 2 over x is not a polynomial. And anything that has an exponent that is a fraction. So if something has x to 2/3 or a negative exponent, so something like x to the negative 1. Okay, this is what constitutes something that's not a polynomial. Now, once we realize that something is a polynomial, we usually try to describe it based on its degree. And the degree is the largest exponent of a variable. So for example, if I have x squared plus x minus 5, the degree of this polynomial is 2, since 2 is the biggest exponent. Okay? Then we have our leading coefficient, which is the number or the coefficient or number of the leading term, which just means the first term in that polynomial. So if I have 3x squared minus 5, the leading coefficient is the 3 that's there in the front. This 3 right here. Okay? Now, you should know that a constant term is just a number with no variable. So in the previous example, that 3x squared minus 5, this minus 5 is the constant term. Okay? And then standard form of a polynomial places the terms in order of decreasing exponents. So if we have, like the example above, x squared plus x minus 5, this is in standard form because my exponents are decreasing. I have an exponent of 2, this exponent of 1 that's assumed or understood since it's not there, and then we have no variable, which tells us that that's an exponent of 0. So if I have a polynomial that's not in standard form, let's say 5 minus x plus x squared, and I want to rewrite it in its standard form, I'm going to find my biggest exponent, in this case the 2. And then I'm going to decrease my exponents. So this x has an exponent of 1. I'm going to go ahead and include that next. And then finally the constant term, or the number, excuse me, that's by itself. Okay, so that was standard form. So our first set of examples ask us whether or not the expression is a polynomial. And then if it's not, explain why. Okay, so in this first case, I'm checking basically, do I have a letter in the denominator? So like 2 over x, or what I would call like a weird exponent. So that's like a fraction or a negative, something like that. Okay, so if we look at this first one, yes, this is a polynomial because there are no letters in the denominator and there are no weird exponents like no negatives or no fractions in an exponent. Number 2 is not a polynomial because it has a fractional exponent. It has an exponent that is a fraction. Okay. Number 3, yes, is a polynomial because there's no variable in the denominator of a fraction and there is no weird exponent. And then number 4 is also a no because it has a negative exponent. Okay, and make sure you're reading the directions on your work to ensure that you're encompassing everything the question asks you for. All right, the next set of questions ask me to write the polynomial in standard form and then identify the degree and leading coefficient. So first, standard form. Remember that means decreasing exponents. So I take a look at number 5 and I see that my biggest exponent is the 2 right here. So if I want to write this in decreasing order, I'm going to start with that 3x squared, then move down to the 6x, and then finally the number that doesn't have a variable attached to it. Okay, we need to find the degree and the leading coefficient. So the degree we said is the biggest exponent, so that one's a 2. And my leading coefficient is the number at the front, which is a 3. All right, same idea in number 6. My biggest exponent is a 1, so I'm going to switch this order here. My degree is 1, and my leading coefficient is that 3/4 that's at the front. The 1 that's understood and the 3/4 in the front. Okay, number 7, we have 4x to the third. Oh, that needs to be a minus. 2x squared plus 8x. This one has a degree of 3 and a leading coefficient of 4. And then finally on number 8, my biggest exponent is a 5, so I'm going to start with 6x to the 5th. Then we have a 3, so we're going to jot that one down. There's no 2, but there's a 1 right here. And then finally the number that's by itself. So this one, the degree, of course, biggest exponent 5, leading coefficient, the number at the front, which is the 6. Okay, now the main purpose of this section is to work on adding and subtracting polynomials. So when we're adding two polynomials, we need to remember to combine our like terms. Oops. And like terms means that they have the same variable, which is the letter, with the same exponent. Okay, now your book suggests possibly adding vertically. So if you're going to work on adding vertically, you need to line up the like terms, and we'll look at that when we get to the vertical addition. Okay, so first we're going to work on adding these horizontally, which is how you would normally add them. And remember, we said we're combining like terms. So if I look at number 9, I usually look at the biggest exponent first because I want to write it in standard form. It'll make it a little easier for me. So in this case, my biggest exponent is a 2. So I have two things that have an exponent of 2. I have my m squared and I have a positive 9m squared. So I'm going to combine those two together, and that's 10m squared. Then I have a 3m and a minus 6m. So I'm going to combine those two together. And that's going to give me a minus 3m. And then finally I have a minus 7 and a plus 10, which is going to give me a plus 3. And this is the sum of those two expressions or polynomials. All right, same idea on number 10. I'm looking at my exponents and I notice that this 3 is the biggest one. So I have 4x to the third minus 3x to the third, which is going to give me 1x to the third. Then I notice I have an 8 squared and an x squared. So 8x squared plus 1x squared is 9x squared. Now, as you can see, this 2x doesn't have a like term, so it's going to stay by itself. And the minus 5 also has no like term, so it'll stay by itself. Okay? So horizontally is typically how you would have learned to add polynomials. But your textbook suggests another option, which is adding them vertically. So I know for some people, visually it helps them if they try to add vertically because they can see a little more clearly what they're trying to do. So if you're adding vertically, essentially what you want to do is make sure that these are lined up so that what you have from top to bottom are like terms. And then all you're going to do is just add like you would add any number. So you're going to add 9x to the third plus 2x to the third, which is 11x to the third. And you're going to add 5x minus 3x, which is a 2x. And this would be your sum right here. So if you have something like number 12, which is not already written vertically, all you have to do is switch it into a vertical form. So I'm going to make sure that I leave a little space at the beginning on the first part so that I can add in my b to the thirds. So then I have 4b to the third minus 4b plus 2 and 9b to the third plus 2b minus 5. Now remember, you have to check that each of these columns has the same variable in it, or the like terms. So then all I have to do is add them. This is 13b to the third. 7b minus 4b is 3b, plus 2b is 5b. 6 plus 2 is 8, minus 5 is a plus 3. And this is the sum of those polynomials added together. Okay? So on Wednesday, we just continued. We actually worked on adding on Wednesday, but we're going to add in subtracting polynomials as well. Now, the big difference here is that in order to subtract, you have to first distribute the minus sign. And then once you've done that, you're going to go back and combine your like terms, which is what we were doing with the adding. Okay? Now, again, vertically, you would have to align the like terms in the same column in order to use the vertical method. All right, so if we look at number 13, first thing I'm going to work on is distributing this minus sign. Okay, so this is our extra step here. So that leaves me with 11m squared plus 3m minus 6, and it only distributes to the second parentheses, whatever's behind it. So it's going to give me a minus 9m squared, a plus 6m, and a minus 10. Remember that distributing a negative just changes the sign of everything behind it. Once I've done that, I'm back combining my like terms. So 11m squared minus 9m squared is 2m squared. Plus 3m plus 6m is plus 9m. And then minus 6 minus 10 is a minus 16. All right, and we're going to do the same thing here on number 14. So we have 7x squared minus 6x. Distribute to change the signs. So 3x to the third minus x squared plus 5. And then I'll work on my like terms. So I notice that I have a 3x squared that doesn't have anybody like it. So we're just going to rewrite it. We have 7x squared minus x squared, so plus 6x squared. Then my minus 6 and my plus 5 don't have anybody like them, so they're just going to sit the way they are. All right? Now again, the second option is to work on it vertically to kind of help you align things. But you have to remember that going up and down, you have to see like terms. Okay, so check that up and down you have like terms. Once I know that, I'm going to make sure that I distribute this negative. So it's changing the signs of everybody. So this becomes a minus 2x to the third, a plus 3x, and a plus 5. So 5x squared minus 2x squared is 3x squared. 3x plus 3x is 6x. And minus 12 plus 5 is a minus 7. Okay? Now remember we said when we're aligning them, we have to make sure that the like terms are together. So when I rewrite number 16 vertically, I'm going to make sure to leave a space for this b squared. So I'm going to kind of skip a spot. And when I write the second part of my my problem, I'm going to go ahead and change the signs. So this is a minus b to the third, a minus 2b squared, a plus 6b, and a plus 5. Now double check, make sure that everything that's in a column is a like term, and then we can go ahead and combine. So 5b to the third minus 9b to the third is, 4b to the third minus 9b to the third is minus 5b to the third. This minus 2b squared has nobody like it. Negative 7b plus 6b is a negative 1b. And then a 2 plus 5 is a plus 7. Okay, now this vertical method is just another option to give you something else to use if you feel like the horizontal version is giving you a little bit of trouble. So it's not necessary. You don't have to know how to use it that way, but it's another option to help you out if you're stuck. Okay, and then the last thing is just kind of combining it all together in the idea of a distribution in general. So you'll notice on number 17, this minus sign is going to need to distribute to this parentheses. And really the second parentheses is going to be distributing a plus, but that plus sign is not going to change anything. So we have minus x to the fourth minus 6x plus 7 plus 3x to the fourth minus 5x plus 9. Looking for my like terms, I have minus x to the fourth plus 3x to the fourth, so that's 2x to the fourth. I have minus 6x minus 5x, so that's minus 11x. And then plus 7 plus 9 is, of course, plus 16. All right, now if you have something like number 18, where you have a bracket and then also a parentheses inside, remember we start by working on the inside of the bracket and see what we can do with the parentheses. So in this case, this negative sign is going to distribute to everybody. So we have 7x squared minus my bracket, 3x minus 2x squared minus 8x plus 14. I'm going to go ahead and combine my like terms here. So this is 7x squared minus negative 2x squared minus 5x plus 14. Now this negative outside also has to distribute. So we have 7x squared plus 2x squared plus 5x minus 14. And of course, these two are my like terms. So that's 9x squared plus 5x minus 14. All right, we got one more example. We're not going to worry about the area. We're just going to work on 19 and then we'll stop there. So on 19 now we actually have numbers that we need to distribute. So this 2 is going to distribute to everything in the parentheses. This negative 5 is going to distribute to everything in the parentheses. And then this 3. Once I've done my distribution, I'm going to see what I can combine together. So 2 times 4x to the third is 8x to the third. 2 times 7x squared is 14x squared. And 2 times negative 5x is a negative 10x. Negative 5 times 2x squared is a negative 10x squared. Negative 5 times negative 9x is a positive 45x. And a negative 5 times positive 8 is a negative 40. And then finally, 3 times 5x to the third is 15x to the third. And then 3 times 15 is 45. Okay, we're looking for our like terms. The biggest exponent I see here is the x to the third, and I have 2 of those. So those are adding. 8x to the third plus 15x to the third is 23x to the third. 14x squared minus 10x squared is positive 4x squared. Minus 10x plus 45x is a plus 35x. And then finally, minus 40 plus 45 is a plus 5. All right. And like I said, we're not going to worry about the area right now. If we have time later, we'll come back to it. But for the moment, we're going to go ahead and skip that. Okay, so I hope you find the video helpful. And if you have any questions, please come see me before or after school.